Hi, welcome to the third session of our Python for Maya Artist series by now. Today I want to go over some complicated utilities that Python has to offer that can make your code more readable. And I think it's important to know that these utilities exist, but I don't expect you to remember them. Even I don't remember them after all this time. So you can often find like Python documentation and then search for the name of a utility and then find either tutorials or official documentation pages about it. And yeah, I think if I mention them now, they might ring a bell later, and you'll be able to find more about them whenever you need them. So the first utility is going to be len, but before we do that, we need a list of data. And I think a lot of these utilities are going to be working on lists. So I'm just going to create some objects in the scene. I'm going to select them. I'm going to import cnds. I'm going to get the selection using the ls function. And I'm going to say selected objects equals this list. And I will print the list just for clarity. That is our selection. And so the first function is called len, and it gets the length of a list. And that is 3. We have 3 items selected. One nice thing worth mentioning is that this also works on text, which I use less often, but it might be nice.
Also, when we mentioned in the last version that you cannot go above a certain element in the list, or you cannot go below a certain element in the list when we go from right to left, you can use length to check if your list is a certain length, and then if you want to get a certain element and that's outside of the boundary, we can actually use this.
Yeah, exactly. So if we try to get the third element from the list, again, we come from 0, so this is 0, 1, 2. And 3 gives us that index error. And if we have the length of the list, then we could say if 3 is larger or less than the length of the list, then we get the third element. And that makes it, got a bracket too many, that will make it decide not to try this, and therefore we don't get an error. So if I put another print here, you will see that it doesn't print because it doesn't evaluate this code, because 3 is out of bounds. And if I say this is going to be 2 and this is going to be 2, it will print test, and it will print the second element in the list, or the last element in the list. And this is useful when you, for example, get values from interface elements and you want to double check that they're going to avoid causing any crashes or errors like these index errors. The next useful function is called range, and it kind of falls in line with the len function. So I have the num selected objects, for example, is the length of the list. Then there's the range function, which gives the which creates a new list, which is just the index numbers that you could be using. So if you print these selected objects, this is 0, 1, 2. So these are the valid items in the list. And if we get the number of objects, which is 3, and we get a range, it will create a list that is length 3, and it will give us 0, 1, 2. And this I use very often, for example, when I have 2 lists, such as a list of objects and a list of positions where they need to go. Then I can, in a for loop, for example, for number in range, print number, print selected objects number. This is now a valid index, so if I do this loop, I get the number associated with the object, and I could have multiple lists of data. I could print more stuff here if I had more stuff available. So it's very easy to pair up a piece of data with an object.
I think this is also a good way to explain enumerate.
Yeah, exactly. I actually want to go into zip first.
Okay.
So the if I have this range, I'm going to store it somewhere. My range equals this. I'm going to print my range because I'm not sure if this is a list or not. It is. I think in a future Maya version, we will have to write it like this. So I'm going to do that now. So maybe get used to the fact that a range needs to be put into a list function in order to be displayable. So when I print my range, that it actually makes sense. And given that range, I'm going to remove this because I'm going to just replace the code with the variable that I created. I can also do a zip function, and a zip function takes two lists. So I have a list of numbers, 0, 1, 2. I have a list of objects, and they are the same length. And when I zip the two lists, my range, comma, selected objects, what this does is it creates a new list where every item is a tuple of the first item in both lists, and then the second item in both lists, and the third item in both lists. So if we do a for each pair in this zip, we can print, for example, pair 0, and we can print pair 1. And that gives us the same thing as before. It has the number as pair 0, and it has the cylinder as pair 1, like you could see here. But this is just the for loop going over these pairs and then unpacking that data into two individual print statements. And like Perry just mentioned, there's a function called enumerate, and it actually does all of this in one. So sometimes that is exactly what you need, and it can make your code a lot shorter. So I don't need len, I don't need range, I don't need zip to combine all of this stuff. If I just get those selected objects, I can do for pair in enumerate selected objects, print, well, I'm going to print the pair first, so you can see that that is also a tuple. And it gives us a 0 with the cylinder, and a 1 with the sphere, and a 2 with the cube. So we can also copy these two print statements instead of this one, and run that code. And now all we've kind of learned so far, we've condensed into just one function. And sometimes this is exactly what you need. Sometimes you don't want to do this. You want to get the range because you need more than one list, for example, where you combine some of these concepts. But we'll see that later on. Yeah, I think that's kind of what I wanted to illustrate.
Maybe it's also good to talk about unpacking lists in multiple variables.
Oh yeah, that's a really nice one. I'm going to start with the selection. So let's say I want to write a script that only needs two objects. So I have the first and the second object. That is first, comma, space, second, equals the selection. So what this does is actually going to create two variables, and it's going to get this selection as a list, and then the first item in the selection is going to go here, the second item in the selection is going to go here. So that's 0 and 1. But what is a, no, that's not what I wanted to do. What is a nice bonus is that this will actually give us an error if there is too many or too few items in the selection. It is not a very clear error, but it's a start where our code will stop immediately if the user, for example, didn't exactly select two items. And if I do select two items, our script will not break, and we'll actually have the first and second object selected into these two variables. And again, it maintains the order. So if I do the sphere first and then the cube, I can run this code, and it gives me the sphere and then the cube. And that is a very powerful feature. And the cool thing is that this is usable anywhere again. So if I do this enumerate trick, instead of a pair, I can say I have a number, and I can have comma selected object. And because I know that this is going to give me these two types of data, it's going to give me one selected object and one number. And then I can fix up the print to use these variable names. And I can run this snippet of code, and it will still work, but it's now a little bit more readable, where we don't have to use these square brackets, we don't have these additional symbols involved, we just have humanly readable text, pretty much.
I think that's most of it, so I think we can start making a function.
Yeah, I want to start writing a little example with some of this knowledge, and I think what would be fun to create is an alignment utility. So what I want to do is I want to grab two objects. So for example, I put this sphere somewhere here, and I give it a position, I give it a scale, give it a rotation, and then I'm going to select first the sphere and then the cylinder, and And then I want my script to put the cylinder in the exact same spot as the sphere. I think, let me check my notes.
Also, one thing to note here, this is only going to make sure that the channels in the channel box match. So if you freeze transform or if you do anything else or it's parented, it will not work. So we can work on something like that later on, but first of all, we're just going to try and match the channel box.
Yeah, so I want these values to match up with these values. And I think it will work for some of these cases, but as a real alignment script, you generally use a little bit more robust methods. But the first step is getting the selection. We've done this a couple of times by now, so I hope you're getting faster at writing this down. And with that selection, what I want to do is I want to get the first item in the selection as my target object, and then I want to match every other item. And I think what is the best way to do that is to use the pop function that we discussed last time. So lists can pop an item and I will remove the item from the list. What it's also going to do is return the item to us. So we can actually make a variable that says first equals, and now I can select sphere cylinder. I can run this line of code, and if I print the list, you see it's a sphere and a cylinder. And then I can run this line of code, and now if I print the list, you see it's only the cylinder, but you also see that first has become the sphere, because this pop function is not only removing the 0 object, it's also allowing us to put that somewhere safe. And now for the remaining objects, I actually want to create a for loop. So for objects or selected object and selected objects, that's only the cylinder right now. And this object is going to be aligned to the first object. One other thing, well, I'll first do one attribute. I think that's easier. So I can get attribute, get the attribute of the first object. I'm going to get the translate x value, for example. And then I'm going to set attr. And I'm going to set the selected object plus the translate x value. And that's going to be, that's going to copy only this first number. Right, so if I click on this, that works. Now, what we could do is copy paste this a bunch and put in all these attributes, but I don't want to do that. I want our code to be a little bit smarter than that. And I think it's a good habit to get into, because this is maybe a short example, but copy pasting code gets really big really fast. And if you can use for loops cleverly, then it actually saves a ton of space. It keeps your code fitting on one page, and it makes it more readable in the future. So one thing I want is the axes, so I want to copy x, y, z. And another thing I want is the attribute, so I want to copy translate, rotate, and scale. And I'm going to put these square brackets around there, because I forgot. And that's going to create an axis list and an attributes list that I can also create for loops over.
Also note that for the axes, you have x, y, and z. You could also just have the string x, y, z, and that should also work.
Oh, that's a good point. You know what? I'm going to do that because it allows us to demonstrate how lists and strings are kind of similar. So this is a list with 3 pieces of text. You can say this is a list with 3 single characters, and they will also be kind of similar as what I wrote here. Especially if we do a for loop, it will do the exact same thing. For every axis in axes, we will get x, y, z as individual axis values. So let's just go and do that. I'm just going to select all of this code. You can see that that actually works. And for every attribute in attributes, and print that attribute, that is also doing what you expect. It's gonna print these 3 attributes. I'm gonna put more spaces in front of this one. So we're really, for every object, every attribute, every axis, we need to combine all this data. And all the data we need is there, right? So if I put this together, all of these print statements together in the deepest nested for loop, I can run this code and it will print cylinder 1, scale Y, cylinder 1, scale Z. So if I start just putting pluses between these variables, I can actually build this attribute name that we need in the setAttr command. Attribute name equals selected object. And then all we need to add is a dot. That's still something we didn't put in there. And then we add the attribute, and then we add the axis. In hindsight, we could actually put dots in front here. Just say dot, 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 and then we don't need this one anymore. And then if I print that too, you can see it all come together in this nice attribute name. That was a cat standing on a spacebar. And now I can actually just put more space in front of this stuff as well. Because instead of this translate x first selected object, I get the attribute name for the selected object. And I can do the same for the first object. And then this is not just translate x, this is the attribute value that I'm gonna get from the first object, and I'm gonna set on the attribute name, which is the selected object. And this should actually copy all of that stuff. Boom. So without copy pasting getAttr or setAttr a bunch of times, we just wrote a few for loops and have a few lists, and it keeps our function really, really short and nice. And by setting this up by getting the first object from the selection and then going over the remainder of the selection, what we can actually do is we can create a bunch of primitives here. And just, you know, they could be anywhere. We're just going to overwrite where they were. And I can select all of them and say, let's align them with this sphere. And I run this code. Oh, I should select sphere first, or the cylinder, it doesn't really matter. And then select all the other ones. Then we're aligning to the plane now. If I play this, then they're all going there. And since this was kind of confusing for me to use, I think what Maya often does is you select stuff first, and then the last one is what you're going to interact with. So when you parent, it's always, everything is going to be parented to the last thing you select. So instead of this, this 0 over here, I'm going to put a -1 over there. And then I'm going to select this and press -1, so it's going to align with the last selected object. This is now not the right name anymore, so I'm going to change first to last as well. I think that kind of wraps up what I wanted to show. I think there were some more things to go over in terms of documentation and help.
Yeah, so because we're now using a lot of new information, like we use enumerate, we use zip, we know a little bit more about lists. So you can find all of that on the Python documentation online. So for instance, if you just search for list or enumerate, then most of the time you can find it within the first couple of searches. Python is very well documented, and Stack Overflow has a lot of information.
No. I'm surprised that Python documentation is so low on the list. Maybe because enumerate isn't searched for very often.
So over here you have like a lot of information on functions, and I believe enumerate is one of them.
So one thing I want to quickly mention is that the Python docs have version numbers, and Maya is currently on 2.7, so you want this really old documentation. And then we can Control F, and always Control F and try and find what you're looking for, or put it in a quick search. So we can see enumerate is in this list of stuff, and there are some examples on how they enumerate the seasons, and then they pair up with numbers.
They also have sometimes this equivalent to, so they actually tell you what the command is actually doing for you.
Yeah, so this is kind of the source code behind the code, behind the function.
If you don't want to search for this, or if you don't have access to the internet, you can actually use simple functions in in Maya itself or in Python, and one of them is called help.
So let's run help enumerate.
And this is a little bit, sometimes a little bit difficult to read because you have to really go and search into your output history to see what documentation says, but this one's very small, so that's quite easy. So over here you get the same information, but then just as ASCII file.
Yeah, it's they don't really do the code samples that we've seen on the documentation, but here's they show kind of what comes out of it, and they try to explain what goes into it. But I find these to always be very kind of programmer term heavy, so it's a little bit hard to keep up with the lingo sometimes. But still, the fact that it's there, and not all of this is as confusing as this one, so we can probably find better examples as well if we're looking for help.
Yeah, for instance, if you do a list, might be something that's going to
Help on list. That's really long.
In the first few sections, you get like double underscore and then what the function does. Those you can most of the time ignore. They have some extra functionality on how to use like the plus or the equals or that kind of stuff. But then when you go actually into the functions, those don't have the double underscore, and then you actually can see what kind of functions a list actually has.
Yeah, so we discussed a few of these, but there are a lot of them. And if you're ever looking, for example, you want to sort a list, you want to reverse a list, probably this stuff exists. You just have to search for it.
If this is a little bit more difficult or too difficult to find or to go through, you can also use dir, which actually returns a list of all these functions.
I should not use the word list in there. You need a variable with data. So, for example, my attributes is a list. So if I print type attributes, I get list. And then dir is useful on the attributes, not on the word list.
You can still do list, I believe.
Are you sure?
Yeah, because it's actually using the function. It's just dirring all the elements in the function.
Oh, nice.
And then because this is now a long list, you can also do a for loop over this and just print all of them to make it a little bit more humanly readable. Then you have an inkling of what kind of functions are available to you on the current type or current function itself.
Right, so this is kind of without the documentation the same list, but it might help you succinctly look for something you recognize. So we talked about append and pop. If you forget the name of those, this might help you find what's going on again.
In this case, because we only want to have the humanly readable functions, we can also just do an if check to remove the elements that have double underscores before. Maybe you want to talk about that.
Oh, that's a cool idea. Yeah. So because strings are like lists, we can do this square bracket 0 and square bracket 1. And we could say if the possibility starts, so that's double equals to compare with an underscore, then we might not want to print it. So I should put not equals, so exclamation point equals underscore. And because it's always double underscore, I'm just going to do 2 if checks for now. There is a slightly shorter way to write this, but it's a lot of data to cover, a lot of information already. So let's just stick to what we know. And that should give us a very succinct list of what we actually have access to. Okay, I think with that, we can wrap it up.
That covers it.
So thank you for watching and I hope you learned something.